This is a brief introduction to Module 1, which covers Chapter 1. This module has 3 sections, which is first of all, in 1.1 we'll talk about definitions and terminology and obtain a vocabulary so that we can talk about these problems that we're going to study. In section 1.2 we cover initial value problems and in 1.3 models, and we'll talk more about those in just a moment. One of the main definitions that we're interested in is what is a differential equation, and concisely speaking, it is just an equation that has at least one derivative function. Some examples of them are these 3. Now here, for example, I have dy dx plus y equals x plus 1. So my dependent variable is y. It depends on x, and I can take a derivative with respect to x. And as you can see, there's an equal sign, so we have a differential equation. The same holds here. We have 2 derivatives that appear, the second derivative of x, the first derivative of x. And in this case it is with respect to t, and we can see that by seeing the independent variable here. Now this equation here you might not be as familiar with, especially this symbol. That symbol means partial, and the idea here is that u depends on 2 variables, t and s, and instead of taking derivatives we take what is called a partial derivative, or a derivative with respect to one of the independent variables that the function u depends on. And so each of these are considered to be a partial derivative. There will be some qualifying criteria or some things that we're interested in understanding. For example, which type the equation is. It is ordinary if the derivatives that appear in it are just normal derivatives that we're used to, such as in this equation and this equation down here with the x double prime. Now when it comes to partial, that means that the partial derivatives are present in the equation, and from our examples that would be this equation here with the partial derivatives of u. We're interested also in speaking about order. Order has to do with what the highest derivative is. For example, this equation here is second order, and the other 2 are first order because only first derivatives appear. And finally, a couple of other concepts that we'll be interested in are understanding the solution type, whether it's implicit or explicit. And by solution we mean a function that can be plugged in here, for example, and satisfy the equal sign. So if I found a function that I could plug in here for y and then also plug in its derivative here and I get x plus 1, then this first equation would be satisfied, and that would be a solution to that equation. And then finally we'll also be interested in linearity, and you guys will read about that in the chapter about what that means. Section 1.2 will cover initial value problems, and essentially these are problems that have a differential equation as well as some initial conditions. You'll notice that depending on the order, which here is the second derivative, that's how many conditions you will need. Now why are we interested in this, and where does it come in? For example, suppose we have the differential equation y prime equals 2x. Quickly probably you can think of a solution to it. Maybe x squared plus 1, it would solve that, because the derivative of y is 2x in this case, if this is y. But then I could do the same for any constant c. And well, the initial conditions generally that just allow us to find out what those constants are. So in this case, if I was to say that I needed to know that at 0 my function is 3, then that would allow me to find c and understand that this is the function that solves that differential equation and holds on to that initial condition. Finally, section 1.3 we'll talk about models, and you'll read about models, and in this section basically we want to understand why we study differential equations. So you'll see this diagram in the textbook, and the idea is that you have a real-life problem and you make some assumptions so that you can somehow express the problem in terms of differential equations. You get a mathematical formulation. Then you can solve those differential equations and get some solutions and try to understand those solutions by displaying them, and maybe you can graph them or something like that. And then check the model to see, and check your solutions to see if they predict what you would expect. If necessary, you alter those assumptions to add more reality to the problem, and you continue the process again. This is the idea of a model.